So in this session we are going to discuss about the inbuilt functions that are used in C programming language. So for example, here we are going to discuss about the inbuilt functions that are used specific for the mathematical operations. So let me just begin including my preprocessor directives as usual, and for the mathematical operations we have to include the header file, that is math.h. So the header file that, or the preprocessor directory that we are going to use for the mathematical operation is math.h in C. So here I'm just starting my main function definition over here. So let's say for example, the first function that I'm going to use is the absolute function. The absolute function is the first function that I'm going to use in this particular piece of code. So this particular absolute function, it will actually accept a input argument that is of integer data type, and it will try to return the positive value of the integer. So let's say for example, I'm trying to give the absolute value of minus 5 is, so percentage d. So I'm just passing the value that is minus 5 to this particular function, and simply I'm using the getch function, and I'm returning an integer value for my main function. So this is my function definition for my main. So when I'm trying to run this particular piece of code, you can see the output, that is the absolute value of minus 5 is 5. So basically ABS is the function that is getting called for a mathematical operation, that is to find out the positive value of any integer that is getting passed. So even if I'm going to give a positive value for this particular function, I'll be again getting a positive value only. So again, when I'm trying to run this particular piece of code, you can see the absolute value of 5 will be again 5. So whether the value is positive or negative, this particular function will return me the positive value of the integer value that is getting passed in the function. So next we are going to see about the function that is power. So let's say for example power, this particular function returns the power value of y on top of x. It is trying to return the power value of y on top of x. So the input arguments for this particular function should be of double data type, and the output also will be in the format of a double data type. So let's say for example, I'm trying to print the power value of 2 power 4. I'm trying to print the power value of 2 to the power 4. So just I'm trying to pass the input argument in terms of double value or double data type, and when I'm trying to run this particular piece of code, you can see that 2 power 4 is 16 actually. So it returns me a value of 16 in terms of a double data type. So this particular function power, it will accept the input argument both in terms of a double. So it should have two input arguments. This particular function should have two input arguments, and both the input arguments should be of double data type, and the return value of this particular function will be of double data type. So next we are going to see about the function that is ceil. Ceil, actually what it does is it will accept a input value in terms of decimal, or let's say for example, technically speaking, it will accept a double data type value, and it will round off to the next integer. It will round off the value to the next integer, and it will return the value in terms of a double data type. So let's say for example, let's say for example, the ceil value of 3.1415. let's say for example, I'm getting the pi value 3.1415 is percentage LF. So LF is actually used to represent the double data type. The character format represents the double data type. So now I'm just going to call the function that is ceil, and I'm going to pass the value that is 3.1415. So this is a function that I'm trying to call. So when I'm trying to execute this particular piece of code, Here you can see the output value. So the value that is 3.1415 is being sealed, or it is rounded off to the next integer value, that is 4. So again, similar. So for this particular function seal, it will round off to the next integer. Whatever value is getting passed, that will be rounded off to the next integer. So preferably it will accept a value in terms of double data type. This particular function is going to accept the input argument in terms of a double data type, and the return type of this function is also of double data type. So seal will return a value in terms of double data type by rounding off the value to the next integer. There is another mathematical function called floor. Again, for floor we have to give a value in terms of decimal, that is of double data type, and what it does is it will round off the value to the previous integer. So round off the value to the previous integer. Again, the return type of this particular function is of double data type. So here I'm just trying to print the floor value. So let's say, for example, the floor value of okay, I'm taking the same pi value, 3.1415 is, again, its a return data type is double. So here I'm trying to call the function that is floor by passing the pi value, that is 3.1415. So when I'm trying to execute this particular piece of code, you can see that the floor value will round off the decimal or the float value in terms of the previous integer. It will be rounded off to the previous integer. So seal function is actually called as the top up roundoff, and floor function is actually called as the bottom roundup. So this is another these are the two functions that we are going to use for the rounding off purpose. So next we are going to see the logarithmic functions that are available in math.h. So the first function is log of x. So the log of x will perform the natural logarithm on the x value. So x value will be in terms of a double data type, and the function will return the value in terms of a double data type. So the input argument should be in terms of a double data type, and the output also will be in terms of the double data type. So log will actually perform the natural logarithm on the input value. So let's say, for example, I'm trying to print the log value. I'm trying to print the log value of 2. Log value of 2 is %LF, and I'm just calling the function log of 2.0. So this particular function will retrieve me the logarithmic value of 2. So this is actually the natural logarithm that is getting applied on the value, that is 2.0. So what about the common logarithm? So for the common logarithm, what we are trying to do is, for the common logarithm, here we are going to make use of the function that is log 10. So here I'm going to make use of the function that is log 10. So this particular function log 10, it should again accept a input value in terms of double, and it will again retrieve a value in terms of double, and this is going to perform the common logarithmic function on your input argument, that is x. So here what I'm trying to do is I'm going to retrieve the common log value of 2, and here I'm just rewriting it as natural log value of 2. So common log value of 2.0 will be, I'm just calling the function that is log 10. So which means log base 10 has been applied on the value that is 2. So when I'm trying to run this particular function, here you can see the common logarithmic value of 2, that is 0.301030. So these are some of the functions that we are going to make use using the header file, that is math.h. There are also other functions like sine value, cos value, that is exclusive for the trigonometric function. So let's say, for example, I have a I want to find out the sine value of a specific value. So here let's say /n sine value of 0.3010 is %LF. So I'm just simply calling the function that is sine, and I'm just passing the double value, that is 3010. So here if I'm trying to run the function, here you can see the sine value of 0.3010, and similarly you can call the function cos as well for a specific function. So here what I'm trying to do is I'm trying to call the function that is cos. So in order to get the cos value of a particular value, so this particular function cos can be called, again you have to pass an input argument in terms of double, and I'm just retrieving the cos value of 0.3010. So again when I'm trying to run this particular function, you can see you can retrieve the value of cos, and again you have the tan function as well. And again you have to call the function that is tan. So these are some of the trigonometric functions that we can make use on the value. So tangent value of 0.3010, so this will give me the tangent value of 0.3010. And of course we have the hyperbolic values of sine, cos and tan. So what I'm trying to do is we are going to call the same function added with the h value. So here what I'm trying to do is I'm just going to print the hyperbolic sine, cos and tan value for the input 0.3010. So for this what we are going to do is we are going to just call the function that is sin h, cos h and tan h. That will return me the hyperbolic sine value, the hyperbolic cos value and the hyperbolic tangent value respectively. Hyperbolic sine value, hyperbolic cos value and hyperbolic tangent value. So when I execute this particular piece of code, okay, so you can see the hyperbolic sine value, the hyperbolic cos value and then the hyperbolic tangent value of the given input. So these are some of the mathematical functions, the inbuilt mathematical functions that we can use if you are trying to design some kind of scientific calculators, etc. So if you have any queries related to this particular video, you can just post your questions in the comment section. Thank you.